Okay, now let me fill up the liquid. Mercury I'm going to fill up in a glass tube, and I'm placing it on an horizontal surface. Yeah. Now if you look at this mercury, very nice, simple questions. All these are from advanced paper. I just picked a few. Look at this one. So this is the mercury now. So this is the height. The temperature of this is 95 degrees Celsius. This is 5 degrees Celsius. This is 95 degrees Celsius of this liquid column. And this one is 5 degrees Celsius. They are maintained like this. You can see the height. So there's a mercury is filled up here. So there's a mercury. It's asking find the quotient of thermal expansion of the mercury. Thermal expansion of mercury filled up in a tube in different limbs. Filled up in a tube in limbs that are at maintained at different temperature. Okay, see now. Look at the mercury here. What is the density of 95 degrees? So what is the density of mercury at 5 degrees? Density of mercury at 95. Can you remember yesterday? The density of liquid varies with temperature. Can you remember that particular thing? So is what I just brought a formula now. Let me call this is H1, this height, H2, this height, let it be H3. How to calculate the quotient of thermal expansion of mercury filled up in a tube with tube in different limbs? Okay, now what you can do? What is the state of this liquid at rest? No? What is the state of this mercury at rest? I'll give 2 minutes time. So there's a best question where student, whose help you should take? Fluid statics. Fluid statics, I'm bringing a little bit in thermal expansion. I'll directly start with pressure at A should be equal to pressure at B. Any reason for that? Because what is the state of this liquid at rest? No? So if you look at this particular surface here, if you draw a line, then what should be the net force on it? Must be zero, that one. So therefore the pressure at this, pressure at A should be equal to pressure at B. So let's write down the equation now. Pressure at A why it should be static liquid as these points lie on horizontal line At these points lie on horizontal line in a static liquid. Okay, so there's a primary reason. What is the pressure at A? So we'll start from here. So here air is present. So free surface we have here. We have one more free surface. So I'll start from this free surface. Pressure here P naught. Density of mercury rho 95 G H1. Then rho 5 GH2. This should be equal to pressure at B. How to calculate pressure at B? So I'll write equation from here. P naught plus rho 5 GH2. This is H3. Rho 5 GH2 minus rho 95 GH3. Is that okay? So you have enough of fluid statics. I'm taking help of that one. I'm starting here. P naught plus density of mercury at 95 degrees Celsius means rho 95 GH1. Then I'll move up. So how much it should be? Rho 5 G minus Y negative sign as I'm moving vertically up inside the liquid minus PA equal to 0. So therefore pressure at A equal to this much here. Similarly, pressure at B. P naught plus rho 5 GH2 minus rho 95 GH3. So P naught will get eliminated. So bring all the 90s. So rho 95 H1 plus H3 should be equal to rho 5 GH2 plus H3. We know H1, H2, H3. So what is asking? Thermal expansion of the mercury. How to bring that one? What is rho 95? You can write it as rho 95. You can write it as rho naught 1 plus 3 alpha into 95. H1 plus H3. What is rho naught? Density of mercury at 0 degrees. We don't know. Okay, let it be here. So is that formula okay? 3 alpha, quotient of linear expansion, or gamma if you want, you can find out. What is gamma? Gamma should be equal to 3 alpha. So this should be equal to rho naught 1 plus 3 alpha into 5 H2 plus H3. Okay, substitute all the values H1, H2, H3. Then solve for alpha, you'll get the required answer. So this will be 1 plus 95 into 3, 285. Okay, solve for alpha, you'll get the required answer. Fine. Some questions. Answer will be 6.75, 6.7 into 10 to the power of minus 5 per degree Celsius. This will be answered.
Sir?
Ah.
Sir, it should be rho naught into 1 minus 3 alpha, no, sir?
Oh. Negative sign of forward, no? Yeah, density should decrease, no? Yeah, okay, good, yeah. I'll put in red color, huh? Okay, density, no? Should, yeah. Okay, thank you, yeah, fine. Gamma equal to 3 alpha? I should write gamma, no? 1 minus. Volume expansion should be equal to 3 times of linear expansion. Okay, I'll slide down. say thermal expansion is a very small idea now. Now you should really get into the basic things, you know.